Hello, my name is Arjit Sharma and I am present over here with my teammates Vandan Patel and Pranav Nashte. And today we will be discussing about a project that is predictive analysis of profitability for Hollywood movies. I would like to thank Dr. Brian Hammer under whose guidance we successfully completed this project. So let's get started with the presentation. So contents. These are the following major points that have been thoroughly covered under this project. Introduction. We initiated our project particularly in this field because most of us are related to movies in some or the other way, and we must have admired sometimes that why a movie rated so good by IMDb, movies such as Ace in the Hole ended up being flop, or movies having big budget like Lone Ranger actually needed $150 million to break even. It is noticed that average budget for a blockbuster used to be $113 million in 2000, and in 2015 it has reached to $200 million mark. The scenario is so bad that the failure rate of a movie raised to 60%, and this rate is expected to increase in the coming years. The huge losses faced by movie industry build curiosity in us and lead us to identify what factors decided the fate of a movie. We collected the data of more than 1,000 movies from last 10 years, 2005 to 2015, and wished to predict the profitability of a movie by taking key parameters into account. Here is our project objective. Our primary objective was to perform predictive analysis and to find the impact of dependent variables on the target variables. And our target variable was the profitability of a movie, and the dependent variable we chose were as follows: production budget, revenues from DVD Blu-ray, domestic international box office, first week opening, film characteristics like genre, web reviews like IMDb ratings, and the competition faced by a movie at the time of release. Our secondary objective was to explore new traits while doing descriptive analysis on Tableau. Statement of scope. For obtaining the profitability of a movie, many factors have to be considered, but the data that we accessed was having only few factors responsible for calculating the total profit. We might include other parameters like feedback received through social media such as Twitter, Facebook, or YouTube to improve the model. Television licensing, selling merchandise, music rights, and piracy might be potential factors that can impact on profit made by a movie. Our project included some constraints, like we just focused on Hollywood movies from last 10 years only, and that too of some selected movies. Now I would like to call upon my teammate Vandan Patel to progress further.
Thank you, Arjit. One of the most important and most time-consuming aspect of data mining is data preparation. In fact, it took around 60% of our time and effort in this project to do data preparation. By appropriately devoting time and efforts preparing and packaging, the data helped us accelerate modeling process. The data preparation process involves 5 major steps: data access, data consolidation, data cleaning, transformation, and data reduction. We access the data from opusdata.com, which is used by leading box office analyst company The Numbers. With only limited amount of data that can be extracted by one account, we had to create more than 10 different accounts to gather the raw data. We also designed web crawler to extract IMDb ratings from the website to include the impact of online reviews on profitability. Data consolidation. We used queries and filters to extract variable data, but at the time only 5 variables could be extracted. Hence, we had more than 4 Excel sheets which we later consolidated into one. Another data set of web crawler output which had IMDb ratings in that were consolidated in the main data set. Here is the example of the query which we used to extract the data. Then comes the part of data cleaning. To analyze the data, we ran basic summary statistics using IBM Modeler. Many missing values and 0 values were found in the data set. To handle such records, we used list-wise deletion method in which entire records which were having 0 or missing values were excluded from the dataset. Also, our model predicts the profitability, hence we had to eliminate the movies which faced losses. In data transformation phase, for our analysis, we constructed new attributes. As our dataset spanned for a decade, to give justice to time value of money, we multiplied each revenues and budget with the respective inflation factor to obtain inflation adjusted revenues. We also aggregated all the revenues generated from different sources and subtracted by the budget to get profits and profitability. Later, we classified movies based on the months of their release into categories such as high competition, medium, and low competition. As you can see here, that was done using the counts and respective level of competition were assigned. Then comes the phase of data reduction. We removed variables which were having high correlation. For example, we found that DVD units and DVD revenues were highly correlated. And hence we just considered DVD revenues in order to reduce redundancy. Now, when we considered genres, in that we found that there are so many genres present, hence we clubbed the secondary genres to make a primary. For example, we clubbed black comedy in romantic comedy and the comedy into one comedy field. Then comes the part of descriptive analysis. To get better insights of the data, we process the data into IBM Modeler and Tableau to gain more knowledge of the data which we have. We analyzed mean, median, standard deviation of all the independent and dependent variables. We also found out that most of our data is skewed. With the use of Tableau from our data, we realized that movies which had high opening week revenues were generally profitable. We can also see that in the months such as May, June, July, which consists of summer, they are highly profitable. Also the Christmas season you can see. So this is the season to release the movie to get high profits. From the data we can also see that the movies ratings such as IMDb with the highest rating, also they did not have the maximum number of DVD sales. Also we can see that the trend which the DVD sales followed is that after 2009 there was a sharp drop in the sales of DVD. That was advent of Netflix and internet. We also found that movies genres such as adventure and action, they are highly profitable generally. Also that highly competitive environment can also lead to higher profits. That we see that the general trend that international market is always important in the last 10 years than the domestic market, and the difference in the international and domestic market goes on increasing. Now finally, as we have insights of the data with the use of Tableau and visualization technique, we will proceed towards model building process. For that, I'll call my friend Pranav to explain further. Thank you.
Thank you, Vandan, for providing insights into the data. Now, after all the hard work of data cleaning and data consolidation, finally it's time to put this good data into the model. So, which model to select? It's a question for us. It was a question for us to select a model which could relate to our objective and which could be satisfied with all the data constraints which we have. So, we started delving deep into selecting a model based on our objective. Objective was to select a modeling technique which could classify our films based on its characteristics into a class which we have defined like A, B, C, D, or E. So thus it's a classification problem, and we decided to use a classification technique. And here we have eliminated two techniques, clustering and association models. So we would focus more on classification models. Linear regression, though not classical classification, we would like it since our data is not normal and it is not linear, we cannot use it. Multinomial regression is another classification method, and we have considered to use this model because it does not require linearity constraints or non-normality constraints. Multinomial regression method. We decided to select this method because it's a classification method and it relates to objective, which is classifying a film based on certain parameters. In our case, the independent parameters are continuous, ordinal, or categorical. And yes, logistic regression can take all these types of data as independent variables. Also, the output of multinomial logistic regression would be helpful in the sense that it will give us the odds ratio of a particular film being categorized in a particular class depending upon the characteristics of the film. So that's why we selected multinomial logistic regression. Next, we selected neural networks because it will satisfy the goal of finding the most influencing parameters for classifying the films into the defined class by learning the characteristics of the film. And as required for multinomial logistic regression, this also does not require the data to have linear relationship with dependent variable. Also, it does not require the data to be normal. This is a very good thing for us because our data is highly skewed. Next technique we decided to use was a decision tree using CFA algorithm, and this, it works like a regular decision tree, but they use an algorithm which classifies or splits the data based on the maximum information gain. So here, by using this model, we are expecting to classify our data based on certain critical parameters using the information gain. And the model will go on classifying the data till the data becomes homogeneous. So we are now in a critical stage of a model building process, that is data splitting and data subsampling. So we are splitting our data set into two categories, that is testing and training. We are doing this to access the quality of our predictive models which we are going to implement in our project. This is a critical phase because if we do not split our data in a correct manner, we will get different results each time when we run a model. So that is why I think it's an important stage in our modeling building process. So we decided to give 80% weightage to training and 20% weightage to testing. We did not use a validation data set because we thought that our data set was quite small, and we wanted to feed more and more data set into our training data set to capture more characteristics of the data. So this slide shows the node which we executed in IBM Modeler. So as we can see from here, we have split the data into two sets, training and testing, 80%, 20%. And the criteria which we have used over here is class. So why did we use class as a splitting criteria? First of all, in our training data set, if we get data which has 80% of data from class A, 20% of data from class B, and it does not have any data from any other classes, it would not represent our data correctly. Here is model building process. So this image shows the entire flowchart of a model which we have used for building predictive analysis and descriptive analysis as well as statistical analysis. Multinomial logistic regression. When we executed this node in IBM Modeler, we got the results of training and testing data sets. The accuracy in training data set was about 99, which was exceptional, and in testing data set it was around 87, which is also good. And we also got the significance parameters which were affecting the classification of a particular film into a particular class which we have defined. So from this we can see that budget, international box office, revenues from DVD and Blu-rays, and revenues from sales of domestic box office are the significant parameters which are helpful for the film's profitability. IMDb ratings, opening week revenues, genre, maximum theaters, competition, and month are not that much as influential as above. In neural networks, again we got an accuracy of around 93% in training and around 78% in testing. Again, consistent with logistic regression, we got significant parameters which were budget, international box office, domestic box office, earnings from DVD revenues, and again, as we can see, the significance level has dropped from opening weekend revenue onwards till competition. From this image, we can see that the neural network had utilized multilayer perception as its algorithm. Next, classification tree. Again, when executed, we got a training accuracy of around 78% and testing accuracy of around 47%, which is not as much good as previous two models. But we can see the significant parameters, again consistent with previous two models. Budget is one of the most significant parameters, followed by domestic box office, DVD earnings, international box office, and then onwards the significance has dropped from month to IMDb ratings. Model assessment. So which models should we use? So we have basically used two parameters for classifying or selecting which models to use. It's based on model accuracy, and second will be based on significance level. In model accuracy, we are considering the accuracy of testing dataset as it will give more conservative results. Logistic regression was about 87%, neural networks around 78%, and decision tree around 47%. I can say all these accuracies are pretty much good, but compared to first two, the accuracy of decision tree is a bit on the lower side. Predictor importance. Here we are going to compare the significant parameters which we received from previous three models, whether they are consistent or not with each other. In logistic regression, we got most influential parameters like budget, international box office, DVD earnings, and domestic. Neural networks, the order was same except for international box office and domestic box office. For decision tree, it was significantly different. As we can see, budget was continued to be the most significant parameter, followed by domestic, but there was some order change after that. So which parameter to select from this? We can select the parameter based on model accuracy. We can select based on the logical configuration of predictor importance, or any different other parameters. But since we employed these two characteristics, we would like to select neural network as our final model because it has a good accuracy of around 78%, and also the importance, significant predictor importance, which it has showcased like budget, international box office, domestic box office, and DVD Blu-ray earnings were consistent with other three models. And also from a descriptive analysis, we have found out that international box office is more significant compared to domestic box office. And based on this logic, it becomes more sensible to use neural networks as a model compared to logistic regression. And also the other reason is that neural network can accept any sort of data. It does not require any constraints of linearity or normality, and hence going forward, we can use this model for any type of data as we get more and more new data sets. So after selecting the correct model for our project, I would like to call Arjit for the concluding part. Thank you.
Thanks a lot, Pranav. So here is original vision versus final product we achieved. We started this project with certain goals in our mind, but eventually, while doing project, some changes were required to be done. In beginning, our motive was to identify various dependent variables that might affect the fate of the movie, whether it will be profitable or will suffer losses. We also targeted to achieve a profit pattern of the film industry. Firstly, we had only production budget, revenues from DVD and Blu-ray, domestic international box office, first week opening, film characteristics like genre as a dependent variables. But as we progressed further in our project, we added web reviews like IMDb ratings and the competition faced by the movie at the time of release in our dependent variables. Finally, we built 3 predictive models and acknowledged the budget. International and domestic box office collection and DVD Blu-ray earnings were the most influencing factors that affected our target variable. We have achieved our objective partially in identifying potential factors responsible for influencing profitability of a movie. Because the data extracted from opusdata.com was not including every factors that might influence our target variables. We faced some problem while doing our project. So here's the approach. While extracting data, we faced many problems, such as only 100 movie data set was accessible through one email ID. So, in order to get an appropriate amount of data, we made 10 new email ID. Secondly, in order to add IMDb as a variable, we had to access data through IMDb site, and doing it manually would have been laborious. So we did create a web crawler on Python for extracting IMDb rating for the selected 1000 movies. While cleaning and transforming data, we had to go through the whole data again and again for making it appropriate for use so that we can input in the modeling techniques. We also added new variables in order to get optimized results such as class, which constitute of profit percentage, competition for movies, and the inflation rate. We shortlisted modeling techniques and did the variable selection by performing descriptive analysis on Tableau. Here are the lessons learned while doing this project. We all did our best by being attentive, not only individually but also as a team. We learned a lot of facts while dealing with data and effectively completed the project. We did not trust any single modeling techniques but trusted them as a whole and concluded our results by comparing all the modeling techniques. We did consider all the assumptions that were needed to be taken care of each modeling. So, that would be all. We would like to thank you all for watching our presentation, and if you are having any doubt, please do contact us at the above email IDs. Thank you so very much.